Okay, the final one, 9b, we're solving a radical inequality, so we want to make sure that we do our domain restrictions. So I'm going to hit those right away. What we want to make sure is our radicands are non-negative, so that means our x plus 9 needs to be greater than or equal to 0, which forces us to choose only inputs that are greater than or equal to 9. That's one restriction. Our other restriction is the square root of x, so here's our radicand. That's a pretty simple one. We're just going to make sure we choose x values that are greater than or equal to 0. Now, of these two restrictions, this restriction is going to supersede this one because if we choose numbers that are greater than or equal to 0, they're automatically going to be greater than negative 9. So we can get rid of that restriction. Just keep in mind we can only choose values that are greater than or equal to 0. So now we're going to isolate our ugliest radical. So we got x plus 9. I'm going to isolate that by adding the square root of x. So it's going to be x plus 9 has to be greater than, and I like the square root of x first and then plus the square root of 3. It doesn't really matter, that's just a preference again. So now we're going to square both sides to get rid of our square rooting. That's the inverse. So x plus 9 has to be greater than square root of the first, which is x, double the outside inside, so plus 2 square roots of 3x. Now I can make that square root of 3x because it's square root of x times the square root of 3, which is the square root of the product of those two. Remember, you can combine multiplication, but you'd have to double them. And then I square the last, which is plus 3. So we're going to collect our like terms so that we can isolate this radical one more time. So we're going to subtract x from both sides. Then we're going to subtract 3 from both sides, which makes 6 is greater than 2 times the square root of 3x. Then we're going to divide by 2. And if I divide by 2, we get 3 is greater than square root of 3x. That's all into the radical. To get rid of the square root, we square both sides, so that means 9 is greater than 3x. Then we can continue and divide by 3, which means 3 is greater than x, which, as I said in the last video, I really prefer to have the x on the left side, so that means x has to be smaller than 3. Okay, so we can only, for our solution set, we want every x value that's smaller than 3, so every number that is smaller than 3, but our domain restriction says it has to be a number greater than or equal to 0. So to graph those on a number line, we want every number between 0, including 0, and 3, but not including 3. So open circle on 3. And shading in between to indicate that we want every possible real number in between 0 and 3.